Hello, welcome. Let's try to solve another Leetcode problem. 2371, minimum maximum value in a grid. So we are having this kind of m times n matrix. So it is called grid containing distinct positive integers. As you can see, it is 3, 1, 2, 5. And we want to turn this kind of grid to a final state. It's going to be like 2, 1, 1, 2. And there are two statements. So we have to follow the two statements. The relative order of every two elements that are in the same row and column should stay the same after replacement. So this means the relative order for this is, for example, this is 3 and 1. The relative order, we're going to keep 3 and 1, but we can reduce this 3 to 2. So 2 is smaller than 1, 3 is smaller than 1, it's the same. But we're going to reduce it as much as possible, so we're going to keep it 2 and 1. And similarly for here, this is 2 and 5. We can reduce it to 1 and 2. Yeah. So the relative order is for each row and column. Yeah. We only compare each row and column. For example, this is 2, 1, and this is 1, 2. Yeah. So this is the relative order. But we're gonna reduce the maximum number as smaller as possible. Now let's check the second statement. The maximum number, so this is what I said. Yeah, in the matrix after the replacements should be as small as possible. So this is just the explanation of the first statement. So this is what's the meaning of the relative order. It means R1 equals to R2 or C1 equals to C2. And we should be careful about this is just or, not and. This is just or. This means grid R1 C1 should be more than grid R2 C2. And from the beginning, it is like that, and after replacement, the relative order should also be the same. And here is just an example. And we can also use this example. This is a 2, 4, 5, okay, 7, 3, 9, and we're gonna keep this kind of relative order. So 1, 2, 3, it is okay. This is the relative order, and 3, 1, 4 is also the relative order. So this is for row, and this is for row, and also for the column 1, 3, 2, 1, and 3, 4. It's also the same. Definitely, we want to get the final result of this kind of matrix. Yeah. Now let's just check other examples. Maybe let's just use this example. Yeah. But how can we solve the problem? So one way is by using topological sort. But by using topological sort, it's gonna take time, and the coding gonna be really difficult. Basically, we need to check all the we need to check all the rows and all the columns. A lot of things we need to check. Actually, there is a greedy idea to solve the problem, and this idea is a really clever way to solve the problem. Yeah, because after all the numbers will be sorted. So here, all those numbers will be distinct, but after that, the relative order is gonna be the same by row and by column. Yeah. So for example, here is like 1, 2, 3, and 5. So we want to sort all those numbers like 1, 2, 3, and 5. And at the same time, we're gonna remember the location. So for example, for 1, the location is 0, 1, and for this number 2, the location is 1, 0, and for this number 3, the location is 0, 0, and for this number 5, so the position or location, the position is going to be 1, 1. Yeah. So after sorting, it's going to be 1, 2, 3, 5, and here is the position. Now what we need to do, we just need to fill the numbers inside the matrix, and we're going to prepare a 2D matrix like that. And for the first number, it is 1. So we want to fill 1 into the position of 0, 1. So the position, so this is 0, 1. So it means here. Yeah. So for at this position, we want to fill in a number. So this is 0, 1, 0, 1, row and column. Yeah. So in position 0 and 1, we want to fill in a number, and this number must be from the beginning. It must be a 1. Yeah, because we want to choose the maximum number as small as possible. So for the first number, definitely we're going to choose a 1. So here, we're going to choose a number 1. Now, we're going to turn to the next number. So the next number is 2, right? And the position is 1, 0. 1, 0 is here. Yeah. But at this position, which number we can fill in? We just need to check if there is any number in this row or in this column. So there's no number in this row or column. So this means at this position, we're gonna choose the maximum number of the row and column plus or 1. If there's no number, we're gonna set it as 0 from the beginning. So the maximum of 0 and 0 is gonna be 0 plus 1, it's gonna be 1. So this is the greedy idea. And next, we're gonna check this number 3. Because greedy idea is just checking the sequence. So this number has a sequence. It is increasing 1, 2, 3, 5. So we're gonna fill the numbers also in increasing order. So after that, we can keep the matrix like what required, like the row and column keeps the relative order. Yeah. Next, we're gonna check the next number. It's gonna be this number 3, but the place is gonna be 0, 0. So for here, definitely we want to choose a number 3, or maybe we want to choose a number even smaller than 3. Yeah. But I mean, after sorting, definitely we don't need to use this number. We just need to use the sequence. So it's gonna be 0, 0, this position. Yeah. And for the numbers, which one we're gonna use? Because current row, in this row, we have a number 1. It is the maximum number. And in this column, the maximum number is 1. So it means for the next number, we can at least choose a 2. It means the maximum of the two numbers plus 1 is going to be 2. Next, we're going to choose 1, 1, this position. And we're going to check the row and column. The maximum number is 1. So we need to choose a number 2 because it should be more than the maximum number of this row and this column. And this is going to be the final result. Yeah. Now let's just start the coding. And if we understand the basic idea, the coding is going to be really easy, because normally there's no difficulty for the greedy for the coding of the greedy problem, but the idea is really difficult to think about, and this is the difficult part of a greedy problem. So I will prepare a sorted nums. So this sorted nums, I'm gonna prepare a sorted array, and inside I will prepare a tuple of 3 numbers. It's gonna be grid C because I want to sort it, and the position R and C. So for R in range with a capital R, and for C in range with capital C. And now let me just prepare row and column. It's gonna be length of the grid and length of the grid 0. Yeah. So this nums gonna be sorted, and we're gonna use this nums to get the final answer. And the final answer would be inside the grid, because if we prepared everything about this nums, we don't need to use this grid anymore. So we can just fill the numbers inside this grid. Yeah. But before that, I need to prepare a row and column to record the maximum numbers in this position. So the row and column gonna be 0 times R and 0 times C. So I'm gonna use this row and column array to record the position, and this is the normal way for solving the grid problem. And now we want to check the numbers one by one. So for each of the numbers, I'm gonna use a num R and C inside this nums. And I want to find the first position, and it's going to be grid RC. I will use grid RC because currently this grid will not be used anymore. I just need to use this kind of memory to store my values and just return this kind of memory. Otherwise, I can also prepare a result to the array, but I don't need to do that. Yeah, because I can use the grid as my result array directly. So it's going to be the maximum of row with this position, row R and column C. Yeah, from the beginning, it's going to always be 0. So this is going to be the 0. So for the first number, it's going to be the maximum of 0 plus 1. So it's going to be 1. Now I need to record the position of this row and column. Basically, I need to record the maximum number for the row and column. So row R and column C should equal to the maximum number. It's going to be this number, grid RC. Yeah. Finally, we just need to return the grid. Yeah, maybe you think it has already finished. Yes, this problem has already been finished. It is just like this, and this is the greedy idea. We prepared a sorted array of nums according to the values inside of the grid, and we also need to record the positions. After that, we're going to prepare two arrays, row and column, just need to record the maximum number in the row and column position. And here, we just record the maximum number. And for the next numbers, we just need to check the maximum value plus 1. Maximum of row and column plus 1. Yeah, because basically we need to keep a sequence. So for example, this is a grid, and I wanted to check this number. So currently, yeah, because all those numbers have already been solved, because it is sorted in ascending order, and all those numbers have been solved. For example, the maximum number currently at this row, maybe it is 5. Yeah, and the maximum number in this column is gonna be 6. Yeah, but for this number, definitely for this number, it's gonna be bigger than 6. It's gonna be bigger than 5. So which number gonna be? So it's gonna be the maximum of the 2 plus 1. It's gonna be 7. So this is the idea why it always works. Now let me run it. As you can see, it works.